So, welcome to my dear students and learners. So, today we are going to discuss about the classification. Okay. So, normally we will discuss about the binary classification. So, from the set of data, binary classification is very crispy. Either it will be 1 or 0. That's why means yes or no. Say, uh, if the sugar level is above the threshold, uh, so that person is glycemic. If it is that sugar level is below the threshold, so the person is normal. So here only two decision, very crispy, either 1 or 0. So that's why it's called binary. And the multi-class classification, like there are several options. I will try to explain with some example. So the first will go for the binary classification. So for that I created one simple table. So normally uh, normally I used to means earlier I used to learn music. So as a hobby I used to create some of my songs I want to upload in YouTube. Basically I'm I'm an old person and I like melody. So I used to see in if somebody you are familiar with YouTube's and this making the reels and all, then you can understand after when the detailed analysis of the view it will come that age between these and these this many percentage of your viewers are there, like that it is there. So I have taken one example, say this age. So basically I like melody. So this is the your x column, this your first column is the age, and here is the decision that um, if the age is 22, then the person is not liking the melody. If it is 50, he is liking the melody. If he is 32, liking melody. 42, melody. 20 means he is not liking melody. Okay, is liking rocking and this kind of western music, this kind of things. Okay, so here two decisions. The person, based on the age, whether the person is liking melody or not. So it's a very crispy decision. That's why this data will be classified as binary classification. Okay, so I'm creating a new this one, and here let us give the name classification. Classi sorry Classification. Okay, now we all are quite familiar with the things because we have seen several classes. So let us import pandas as pd, then import uh, matplotlib dot pyplot as curve. Okay, then uh, any other thing. Okay, we'll see time to time, see what are the things to be imported. Okay, so let us run it. Now we will try to import the table here dt, that is pd dot read excel, or then here it will be the path Then let us see the path. This one, this is binary PC dot XLSX. Okay, fine. So let us see the DT. If you run, now you can see this is the age and the exact these things are came. So let us split. My independent variable is X here. So DT, it is my age. Okay, and my dependent variable is the decision whether the person like melody or not. So that melody. Okay, now let us plot it and see how it will be. Carve dot scatter, carve dot scatter dot scatter x comma y. If you see, so you see this is like this. Basically this binary classification is fitting a sigmoid curve. Okay, it will looks like this, sigmoid S type. I'm not going to in that mathematics. It's a exponential sigmoid curve is basically the combination of exponential functions. So I'm not going in that details. Now we will try to fit it. Okay, so from uh, sklearn sklearn dot model selection, m- model selection, these are the commands already we are very familiar. Import train train underscore test underscore split. These commands are already we are familiar. Then this will be uh, xtrain, means the sum based on my percentage of the data I will be using for testing and training. Mm, x underscore train, then x underscore test, then y underscore train, then y underscore test is equal to my train underscore test underscore split. Then I will give the, the first data is the two dimensional, so there I will give the here age, correct, age. Then my that is the column name is melody, so it is melody. Okay, over. So here I have to give the test size, so test underscore size is equal to, I am giving 20% data will be used for uh, training the uh, this. So command is correct. Let us run. Yeah. So now let us see what is xtrain. This and x test. Uh, see, 20% data is used for testing, and remaining 80% will be used for training the model. Okay. Now from sklearn dot a linear model import. This is called logistic. The classification it will be done through logistic regression. Logistic logistic regression. Okay. Now I'll define the class. It is logistic regression. Now I need to fit it. So already this command, you know fit, then my X train and Y train, correct? So let us train it. So training has been done. Then let us predict. So with the test data, lr dot predict, then this is X test. Let us run it. See what was the X test? It was 19 and 32. So 19, the lower age people, they don't like melody, which is 0 here, and the age, higher age, that means 32 age, they like melody. Let us check with some numeric value also. Lr dot uh, predict, say say the person age is 50, or you can take 55. Okay, let us check. So you see the output is liking melody, and let us take this age as 15. So you see this person is not liking the melody. Then I'm going to the uh, second example, that is for multi. How I made this? Let us copy the path for the multi-class. Here I taken a few parameters like the blood pressure. This is the blood pressure, the blood glucose, the heart rate or pulse, the cardiac output in liter per minute. So if your blood pressure is 100, blood glucose, that is during fasting, if it is 200, and pulse is 70, and your cardiac output is 6, then I given the class name is 1, which is that person is glycemic. Okay. uh 1 is glycemic, 2 is hypertension, and 0 is normal. So if the blood pressure is 110, the blood glucose is 100, pulse is 80, and pulse is 80, and cardiac output is 9, then that person is hypertension. Similarly, here you can see another, if the blood pressure is 90, blood glucose is 110, pulse is 70, and the cardiac output is 5, then that person is normal. So that means here I have defined tabulated from the real life data. I collected this table where there are three type of classes. One is the person is glycemic or not, whether the person is hypertension, or he is normal. Okay. So let us first import that. So the dt is equal to pd dot read excel that is multiclass dot excel sx. Let us see the DT. Yeah, the same thing. Sorry. Okay, the same thing has come. So here also we need to do the split it for train and testing. So x train, x test, y train, y test is equal to uh, train underscore test underscore split SCDT. So that will be BP, comma blood glucose, comma pulse, comma cardiac output, cardiac output. These are the your independent variable, and the dependent variable will be your that output, means the status of your health, whether you are glycemic or hypertension or normal, and you have to define the test size. Again, I am giving it 20%. Okay. Now what is the error? So now this is the we splitted. Okay, then again we are calling that logistic regression, logistic regression. Then we'll fit it, lr dot fit, then x train underscore x train comma y train. Okay, it is over. So let us see what was my x test. So seeing this, so the person is uh, first one is hypertension, and second will be the normal. So hypertension will be 2 and normal will be 0. Okay, so let us lr dot predict, lr dot predict, so x underscore test. So you see, hypertension means it is 2 and normal means it is 0. You can check with some other value also, lr dot predict. So here the data are very less, so you have to enter more value, then you will get the very accurate. So say the BP is 160, sorry, you give another value, say 170. Then your blood glucose is say 90, that is the fasting, and your pulse is 60, and your cardiac output is 5 or 6. Okay, sorry. So PREDI, sorry. You can check it. So it is, you see, that is the 2 means that person is hypertension. So it is giving the exact result. And you can test the this pair plot also. So for that, import Seaborn as SB. So here this will be SB dot pair plot, that is DT, uh, that is my blood pressure, then my blood glucose, then my pulse, then my cardiac output, then my disease status. These are my table. These were my table. Then hue is the output. Is the disease. Now, if you, what is the error? Is B dot see, these are the pair plot. So this diagonal is your that is for the particular cases, and these are the classes. You see, 0 is normal, 1 is uh, 1 means it is glycemic, 2 means hypertension. So this was all about uh, classification, which is binary classification and multi-class classification. So hope you have understood it, and the same thing, you generate some data by your own and practice it and submit the same as the assignment. Thank you so much. Thanks for your patience.